In this video, I am going to solve this differential equation, in particular, first order linear differential equation. We are going to use integrating factor. So this equation could be sort of thought of as dy over dt plus p of t y is equal to g of t. Okay, that's the general structure of a first order linear differential equation. Here p of t is just the coefficient of y. In this equation, the coefficient of y is 1. And g of t, we really don't need it here, which is just negative e to the power negative t. Now, as you may already know, that we need to multiply both sides of this equation by the integrating factor, okay, which is we define to be mu of t, and mu of t is nothing but e to the power integral of the coefficient of y, which is p of t, right? P of t dt. In our particular example, we got p of t to be 1, so it's going to be e to the power integral 1 dt, which is nothing but e to the power t. So our mu of t is equal to e to the power t. Now I'm going to multiply both sides of this equation, okay, by the integrating factor, which is e to the power t. So if I multiply both sides by e to the power t, I get e to the power t dy over dt plus e to the power t y is equal to e to the power t times e to the power negative t. Now this last side becomes 1, right? It is e to the power t minus t, which is e to the power 0, that is 1. Now the left hand side, by the way, this becomes the derivative d over dt of mu and y. In our case, mu is e to the power t, so this is going to be e to the power t times y. And you can check it. The derivative of this is actually this by using the product rule. And that's how the integrating factor works out. So now on the right hand side, it is nothing but 1. Now what I could do, I could take integral of both sides with respect to t. So that is going to be d over dt e to the power t times y dt is equal to integral 1 dt, right? Now on the left hand side, this derivative and integral, they're kind of going to take care of each other. We are going to be left with e to the power t times y is equal to, on the right hand side, derivative integral of dt is nothing but t plus some arbitrary constant c. Now we are going to solve for y. So to solve for y, I need to multiply both sides of this equation by e to the power negative t. So e to the power negative t times e to the power t times y is equal to e to the power negative t times t, right? There is a t here. So t times e to the power negative t plus c times e to the power negative t. Now these two together is going to give you just 1. So your solution becomes this y of t is equal to t times e to the power negative t plus some arbitrary constant c times e to the power negative t. So this is the general solution to this linear first order differential equation. I hope that this discussion was helpful. Thank you very much.